Solving systems of equations using elimination, lesson 11 notes. Example number 6. All right, so let's start with, do we have opposites? No, we do not. Do we have identical terms? No, we do not. Do we have multiples? So if you want to see if you have multiples, divide larger number divided by smaller number. 5 divided by 3 doesn't divide evenly, not multiples. 7 divided by 2 doesn't divide evenly, not multiples. Therefore, this is one of the none of the above. Since it's none, you have to multiply both equations by the coefficient of one of the variables. So, would we rather multiply by the 3 and the 5 or the 2 and the 7? The 3 and the 5 or the 2 and the 7. Now, a lot of people probably would pick the 3 and the 5, and that's perfectly okay. I'm going to pick the 2 and the 7, and I want you to use the 2 and the 7 for this example for a certain reason, okay? So we're going to use the 2 and the 7. So go ahead and lightly box the negative 2d and the 7d. Okay, since this is one of the none problems, that we need to multiply both equations. All right, I'm going to ignore the signs for now. Since the 2 is on the top, I'm going to multiply the bottom equation by 2. The 7's on the bottom, so I multiply the top equation by 7. Now this is where we have to decide the signs. Well, because the signs of these numbers are different, see how you have a negative 2 and a positive 7? They are already different. So I already have opposite signs. If I already have opposite signs, then these signs out here need to stay the same. So it's going to stay a positive 2 and a positive 7. Because I already have different signs, I need the same signs on the outside. Inside I have the different signs. On the outside I need the same signs. All right, so let's multiply our equations. On the top, 7 times 3 would be 21c. 7 times negative 2d, negative 14d. 7 times 7 is 49. The bottom equation, 2 times 5 would be 10c. 2 times 7d, that's 7 and then the letter d, not 70. So 2 times 7d would be 14d. And then 2 times 84 would be 168. 2 times 84 is 168. Okay. So my d terms get eliminated. They cancel, they're opposites, so the d terms get eliminated. 21 plus 10, 21c plus 10c would be 31c. And then 49 plus 168 is 217. Again, please make sure you're using your calculators when you're doing these yourselves. All right, to isolate the c, I'm going to divide both sides by 31. If I divide both sides by 31, I would get c equals, and 217 divided by 31 is 7. All right, so I get c equals 7. So now I could choose any one of those four equations to substitute the 7 back in. But for me, the only one that seems logical would be this equation right here because it has the smallest numbers out of all of them. So I'm going to use the 3c minus 2d equals 7 equation. I solved for c, so where the c is, I'm going to put parentheses. Bring the rest of the equation down. And the 7 will replace the c. 3 steps now. Multiplication first. 3 times 7 is 21. bring down the negative 2d, bring down the 7. It's a two-step equation, so if you want, you could box your variable term here. We're going to take the 21 to the other side of the equation, maybe. There we go. Since it's a positive 21, the inverse would be negative 21. So they would cancel. Bring down the negative 2d. 7 minus 21 is negative 14. So, one more step. Divide both sides by negative 2. Negative 14 divided by negative 2 is positive 7. So, we have C equals 7 and D equals 7. C equals 7 and D equals 7. Let's see if we are correct. All right, so I have the three, for the C, I made those X's and the D's were Y's. The C's were X's, the D's were Y's. So if I plug those equations in, there we go. There's the two where they intersect. What's the intersection? 7, 7. So we are correct. Please make sure you have everything written down for number 6. If you have any questions, please do not hesitate to ask.